Hello everyone, welcome back to AlgoSTEM's AP Physics 1 free response series. This video will cover the fifth free response question on the 2018 exam administration. 5. Block P of mass M is on a horizontal frictionless surface and is attached to a spring with spring constant K. The block is oscillating with period Tp and amplitude AP about the spring's equilibrium position x0. The second block Q of mass 2m is then dropped from rest and lands on block P at the instant it passes through the equilibrium position, as shown above. Block Q immediately sticks to the top of block P, and the two-block system oscillates with period TPQ and amplitude APQ. Part A. Determine the numerical value of the ratio TPQ over TP. So let's start off with the equation for period. Period is equal to 2 pi square root of the mass over the spring constant K. Thus, for block P, the period would be 2 pi square root of just m over K. But for block TPQ, which have a combined mass of 3m, the period would be 2 pi square root of 3m over K. So the last step would be to format the ratio of TPQ over TP, which would look like this. And this ratio would end up simplifying to just square root of 3. So for part A, the numerical value of the ratio TPQ over TP is square root 3. Part B, the figure is reproduced above or below here. How does the amplitude of oscillation APQ of the two-block system compare with the original amplitude AP of block P alone? In a clear, coherent paragraph length response that may also contain diagrams and/or equations, explain your reasoning. So we're asked to compare the new oscillation of APQ. Well, during this change, block Q fell and stuck to block P. Keyword here is that during this collision, the two blocks stuck together. That means it's an inelastic collision. And in an inelastic collision, kinetic energy is lost. And now all this happens at the equilibrium position of the spring. And for springs, this is when the kinetic energy of the system is at its maximum and all the energy of the system is in the form of kinetic. So let's follow this train of thought on energy. All of the energy of the system will be spring potential energy at the amplitude displacement. And since kinetic energy was lost, which lowers the overall energy, this creates a domino effect, and this decreases the maximum spring potential energy which is reached at the amplitude. So since spring potential is less, that means amplitude would be less as well. So with these thoughts, you can format this into a paragraph. Once block Q lands on and sticks to block P, the two blocks undergo an inelastic collision, which means kinetic energy is lost during the collision. Thus, since this occurs at the equilibrium position when all the system's energy is kinetic, less energy exists within the system. The entirety of this energy converts to maximum spring potential energy once the block is displaced its amplitude. But since less kinetic energy is able to be converted into spring potential, that means the max spring potential is less as well. Since spring potential energy is equal to 1/2 K times the displacement squared, which is APQ in this case, that means that the amplitude would end up decreasing compared to the original.
Thus,
APQ would be less than AP, so we can check out this as our correct answer. So this concludes the fifth question on the 2018 AP Physics 1 free response portion.